keep mine as RE and IM. So if we had a complex number, let's just say we had the complex number Z1 equaling 3 plus 2i. We represent this on an argand diagram by going 3 units in the positive real sense and 2 units in the positive imaginary sense. And it's represented by a line with an arrow. So it looks like a vector. It has length and direction. So this would be how we represent Z1 then on an argand diagram. Suppose I did the complex conjugate of Z1, often written Z1 with a little star. Remember that when you have a complex conjugate of a complex number, all you do is you switch the sign of the imaginary part, so we end up with 3 minus 2i. And if we were to draw this on the argand diagram, it would look something like this. 3 units across, 2 units down. Don't forget the arrow, and this would be the complex conjugate of Z1. And do you notice how it's related to Z1? It's a reflection in the real axis. Now, if we had another complex number, let's say Z2. Z2 was equal to minus 4 plus I. And we were to draw this on the argand diagram, then we'd go minus 4 and plus 1 unit up there. So going from there to there would be our complex number Z2. Now if we were to add Z1 and Z2 together, let's just do that. Z1 plus Z2. What do we get? Well, 3 minus 4 is minus 1, and 2i plus I is 3i. If we were to represent this on the argand diagram, it would be something like this, going from the origin up to there. Okay, so that would be Z1 plus Z2. Now, it's very interesting to relate this to vectors. If I was to, say, call Z1 OA and Z2 OB, then if I was to do O to A plus O to B, let's just put it down here, O to A plus O to B. Remember, in vectors the plus means followed by. Let's see what we get. If I was to draw over Z2 like so, just take a copy of it, and now translate it across here, can you see that we're doing Z1 followed by Z2? What we get is Z1 plus Z2. So in other words, if I called this point on the end here C, Z1 plus Z2 OC, then O to A plus O to B equals O to C. We didn't have to do this. We could have even done Z1, and we could have translated that across and done Z2 followed by or plus Z1, still the same result, this diagonal of the resulting parallelogram. So you can see, I hope, how complex numbers relate to vectors. Now, having said that, suppose we look at this argand diagram and draw Z1 and Z2 back on again. Now if we do Z1 minus Z2, what do we get this time? Well, 3 minus 4 is going to be 7, and 2i minus plus I is going to be plus I. And if we represent 7 plus I on the argand diagram, 7 units here, 1 unit up, we've got this. So this is the complex number Z1 minus Z2. But in the same way, if Z1 is O to A and Z2 is O to B, if we were to take this vector, we can translate this over to here. And that fits in well with our vectors, because if I think what B to A is, B to A would be B to O followed by O to A. And going from B to O is exactly the same as doing the reverse direction, minus O to B followed by O to A. And we can swap this round as O to A minus O to B. O to A being Z1 then, O to B being Z2, Z1 minus Z2. Well, that brings us to the end of the tutorial, but I hope it's given you an opportunity to see how we can represent then complex numbers on an argand diagram and how they relate to vectors.